The lesson that I chose today is on AP Statistics, beginning of the course topic, which would be in my book that I use, equivalent to Chapter 1, Section 2. The topic is on displaying quantitative data with graphs. The lesson objectives today are on constructing and interpreting dot plots, stem plots, and histograms, as well as describing the shape of a distribution and comparing distributions. One of the simplest graphs to construct is a dot plot. Each data value is shown as a dot above its location on a number line. To construct a dot plot, we make a horizontal axis or number line and label it with the variable name. Then we scale the axis from the minimum to the maximum value. Mark a dot on the location above the axis that corresponds to each data value. So let's try making a dot plot. The number of home runs for the New York Yankees for the 18 games played in the 2018 season are as followed, listed below. So we're going to create a dot plot by starting to look at the values. We have values that range from 0 to 4. So we're going to start with listing or labeling. The bottom is already labeled number of home runs for the New York Yankees for 18 games played for the 2018 season. So I'm going to start by simply making my values and numbering it on the dot plot. Then we're going to put a dot as a count for the number of home runs for each of our 18 games. So when we're done, we should have 18 dots on our dot plot. So I'm going to start by just plotting all of my different points. We can see by looking at our data that we clearly are going to have data that will be skewed. We'll talk about in the next section coming up the idea of what it means to be skewed data. When we examine our distribution for a quantitative variable, we look for overall patterns and departures from the patterns. We'll describe the overall pattern of a distribution by the shape, center, outliers. These are individual values that fall outside the overall pattern and spread of the data. We'll describe the shape and the center, similar to what we've done in the past in the last section of our chapter on the displaying the data and looking at types of center. So we've already defined center using the median or the middle value. We've already defined spread, as a reminder, as a range, and the shape is what we'll talk about as well in this lesson. So don't forget your socks for your shape, outlier, center, and spread of your data. In this example, then, we'll talk about and take a look at what we have for the shape, overall shape of the data. We haven't defined yet exactly what the shape will be, but we'll take a look at in general what the shape of the data might be here. We'll also look at what we think might be potential outliers, the center, and the spread of the data. So we'll define the shape of the data again in just a few minutes here, but we can see that the main part of the data is sitting to the right of the graph, towards the 22 through the roughly 33. Then, if we take a look at the outlier, an outlier potentially might be as it looks. Perhaps at 14, we'll learn how to exactly tell what an outlier value is according to a type of formula that we'll use to find it. The center of the data we could easily find in this problem by taking a look at where, as we looked at the dots and looked at the data itself, the middle of the data lies. We can also find the mean or average. We'll be discussing mean and average coming up in our next lesson or two. And then we also have our spread of the data. The spread of the data is, in this case, we'll look at the range of the data. As we move further, we'll look at other ways to tell what the spread of the data might look like. Now we'll talk about the shape. Roughly symmetric distributions have left and right sides of the graph approximately as mirror images. A right skewed, or as we say, skewed to the right distributions have the right side of the graph much longer than the left side. Left skewed distributions have the left side of the graph much longer than the right side. So if we take a look at our graphs, we want to kind of think of these as the idea of skiing on a hill. So the first graph is roughly symmetrical. We're on a hill, we're going up the hill, we get to the top and then go back down the hill. Skewed to the left means that the left side of the data is much longer than the right. So if again I look at this idea of the skier, we're going from the right to the left. So skewed to the left, we're going downhill. Skewed to the right is longer on the right side. So again, from this one, as we can see, if we kind of think of the data as going from right to left, going the downhill idea, the skier is going down the hill, we can see that the more data is skewed more towards the right. Our number of modes, what they call major peaks, sometimes can also affect the data. Next we'll look at stem plots, or what are called stem and leaf plots, a simple graphical display for small sets of data that give us a picture for the distribution are called stem and leaf plots. They include the actual numerical values. How do we construct a stem plot? First we separate each observation into a stem, all but the final digit, and a leaf, the final digit. Then we're going to write all possible stems from the smallest to the largest in a vertical column and draw a vertical line to the right of the column. We'll then write each leaf in the row to the right of the stem. Arrange your leaves in increasing order out from the stem, and always remember to provide a key that explains in context what the stem and leaves represent. So let's try it. We're going to make a stem and leaf plot for the number of miles driven to work each day for 20 people. We'll start with our vertical line. We're going to look at the numbers that we have included in our data. As we notice, our first digit we're going to have is a 1. Our second digit we have some in the 20s, so a 2. We have some numbers in the 30s, some in the 40s, and so on. We have one that goes all the way up to 80. We'll add in our numbers then, and we'll keep track of where we are. 23 then is a 36, 10, 20, but remember we said we have to put them in the correct order. So I'm first going to just put the numbers as they go on here, and then we'll reorder them when we're done. 15, 18, 12, 10, 15, 22, 11, we have a 45, 14, 22, 12, 30, 80, 15, 10, and 25. So now, as we look at our data, we can reorder our data. So I'm going to reorder this in the correct order. I'm going to rewrite the numbers from the first one over down at the bottom so that I know what numbers I'm using, and then I'll just rewrite them back in my stem plot. Now I'm going to take and rewrite that data in order back in my stem and leaf plot. Finally, we need to make sure we write a key. Don't forget about the key. One value is all you need and what it represents. So we can put any number. We can start with the first one, for example. So we would put 2 with our vertical line 3 represents 23 miles driven to work each day. When data are bunched up, and sometimes we have a lot of data in one part, we can get a better picture of what's called by splitting stems. So that would be, for example, if you had numbers in the digits column, a lot of numbers, and you needed to split up so that because you had so many numbers, we could list it something like this on the left side and split it up. So we could have 2 of each number, perhaps 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. If we have 2 distributions of the same quantitative variable and we want to compare them, we can use what's called a back-to-back stem plot with common stems. So this would be, for example, I gave an example here of math test scores and history test scores, and we can look at reading each of the test scores and then compare the different types of test scores. You can use back-to-back stem plots in a variety of different examples and ways. A histogram is a graph of a distribution of one quantitative variable. So this is the third way that we can look at data. How to make a histogram. You divide the range of data into classes of equal width. Find the count frequency or percent, called relative frequency, of your individuals in each of your classes of your data. You label the axes and use an appropriate scale, and then draw your histogram. Draw the height of the bar as the frequency. The bars should be next to each other or touching unless there are no individuals in a particular group or class, as they call it. So let's take a look at a few things first about histograms that we want to be sure of. Don't confuse histograms and bar graphs. Histograms are for quantitative data and bar graphs are for categorical data in general. Don't use counts in a frequency table or percents in a relative frequency data. Use percents instead of counts on the vertical axis when comparing distributions with different numbers of observations. So let's try it. If we count up how many of each of the presidents that we have listed here at the age of inauguration, we have 2 in the first category, 6 in the second, 13 in the third category of ages, we'd have 11, 7, and 3. I'm then going to label at the bottom each of my values looking at the age ranges. So I have 40, 45, 50, 55, 60, 65, and 70. Notice I have it labeled age in years and frequency over on the side as well. Then I'm going to label on here at the top, going all the way up, my frequency. So we'll start with 0, 2, 4, 6, 8, 10, and 12. We will then draw in our lines, and we're going to start with 40 to 45 had 2. Then we have 6 for 45 to 50. '50 to 55, or 50 to 54, were 13, so we're starting with that number at the next line. So next we have 13, so we're going a little bit above our 12 here on our graph. '11 is for the next one. Next we have 7 and then 3. We'll try to make our graph here so that the bars are the same width. We want to try to make them the same width when we draw them. And now you can go to the Quantitative.com and type in the student login code to see if you understand some things about dot plots, histograms, and then looking at the types of data, as well as stem and leaf plots. So if you click on the www.socrative.com and log in using the room code, you can then complete the assessment for today.